Okay, so lesson 10, we're going to talk about some key features of quadratic equations when they are in standard form. Remember that we're going to talk about two of the three different forms of quadratic. So we're going to start with standard form. We're going to talk about key features today, how to find them, how to identify them, what they are named, and then lesson 11, we will work on graphing them. So remember from last week that a function is a quadratic if the degree, which is the highest exponent, is an x squared. So you can't have radicals, you can't have negative exponents, you can't have fraction exponents, and the highest exponent has to be a 2, then it is a quadratic and it is called a parabola. This is called the parent function, right? If it's just y equals x squared, there are no other numbers. So it's kind of this U shape. That's the name of the parabola that would start right here at the origin. But what we're going to do is talk about how as we add different numbers in there, it's going to change or transform our graph. Okay, so we're going to go through some key features of a quadratic in standard form. What they are on the graph, what they're called, and then on the next page we'll do how to find them. So first notice that parabolas are symmetric, meaning if you folded them in half on this line right here, they would match exactly on both sides. And that line, that dashed line, which is not actually part of the graph, it just helps us in graphing it and in visualizing it. The graph is just the blue part. But that line is called the line or the axis of symmetry.
Yeah, I'm not reading it.
We have these 2 points right here where it crosses the x-axis. Those are x-intercepts. You could have 2, you could have just 1, or you could have no x-intercepts. And we'll talk about what those look like and how that happens. Here's it crosses the y-axis at -3. That is a y-intercept. It will always have a y-intercept. A quadratic or parabola will always cross the y-axis. And this point right here, which is somebody the other day called it the middle, but it's kind of the starting point. It's the point where you could fold it. That point is called the vertex. And the vertex, if we do word problems, is hugely important for most of the word problems. Remember when we were talking about the basketball, that vertex was the peak of, he threw it and our parabola opened downward and went this way, and he shot the basketball. That peak was our vertex. So if we wanted to know how high the basketball went, we would need to find the vertex. So parabolas can either open up like this one, or they can open down like the basketball. This one opens up, and I'm going to show you how, if you're given an equation instead of a picture of a graph, you'll be able to find that. It has either a minimum or a maximum, only one, and that is the vertex. So this graph keeps going up forever, right? There is no highest point. These arrows show that it's just going to continue on forever. But this graph does have a lowest point, which is right here. That's the lowest the graph's ever going to go because it hits that point and then turns around and goes back up. So this graph has a minimum. And what is the lowest point on that graph? How low does it reach? It goes down to -4. So it has a minimum. Whoops, minimum. Is -4. The domain, remember domain are all of the x values, and x is this axis that goes left and right. So the domain means how far to the left does our graph go and how far to the right. So to the left, this graph's just going to keep going forever, up, 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 and also to the left. To the right, it's just going to keep going up, 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 and also to the right. So it's going to go forever to the left and forever to the right. In math, when we say forever, we use infinity. So the left-hand side, those are negative numbers, so that's -infinity, and the right-hand side of the graph is positive. It's always going to be this. Your domain is always going to be -infinity to +infinity for parabolas, because it's always going to continue to the left forever, and it's always going to continue to the right forever. Your range is up and down. Those are your y's. right? Your y's are going up and down. So this graph goes up forever. You see the arrows, it continues up forever. So the highest, when we write them like this, remember this is the smaller number, this is the biggest number. So what's the highest my graph goes? Goes up forever. Forever is infinity. What's the lowest my graph goes? There's not arrows this way. It has a lowest point. And how low is this lowest point? The lowest point's at -4. Also notice with this vertex that the ordered pair for that, the x-coordinate is 1 and the y-coordinate is -4. That y-coordinate shows up a lot. It's in the vertex, it's in the maximum or minimum, it's in the range. So that vertex is a super important point. We also are going to have to write the axis of symmetry. The axis of symmetry, also called a line of symmetry, it's an equation of a line. So you cannot just write a number. If you just write a number, it will be wrong. It's an equation of a line. So this line goes up and down. It's a vertical line. We practiced writing equations of vertical lines in Unit 1. It only crosses the x-axis. So it's only going to have an x in the equation. And where does it cross the x-axis? At +1. So the equation for that line of symmetry or axis of symmetry is x equals -1. So we're going to go through one where we identify everything given the graph. Okay, so which way does this one open? It opens down. What is the axis of symmetry? So the axis of symmetry is the line that cuts it in half. That would go straight down the middle like this. And that's going to be helpful in lesson 11 when we graph them also. But what's the equation of that line? It only crosses the x-axis and it crosses at 3. Where is the vertex? This point right here is the vertex. We need to write it as an ordered pair, 3, 4. This graph goes down forever, so there's no minimum. And the highest that it goes is right here, that highest point on the graph, so it has a maximum. And how high is that point? What's the highest it reaches? It reaches +4. This graph has 2 x-intercepts, right? Remember I said sometimes it'll have 1, sometimes it could have none, sometimes this one has 2. So 1 is right here. That is the point 1, 0. The other one is right here. That is the point 5, 0. It will always have one y-intercept. So it crosses the y-axis right here at -5. The ordered pair is 0, -5. The domain we said was always -infinity to +infinity, because this graph's going to go left forever and right forever. The range are the y's, that's up and down. So my graph goes down forever. So the lowest or smallest it gets, it goes forever. So it's -infinity, because numbers down here are negative and forever is infinity. What's the largest my graph goes, or my highest my graph goes, is up here at 4. So we have the last two now are you have to find everything. So given an equation, we have to find all of these same things, but we don't have a graph now. We have an equation. So I'm going to write down, there's a formula in here that you need to write down, and I'm going to show you how to do it. And just to kind of visualize, we're going to draw a little sketch of it as we go. Okay. So we need to figure out which way it opens. Remember that we have A, B, and C here. So my A is 1, my B is -2, and my C is 3. It opens depending on your A. If A is positive, if it's greater than 0, it opens up. If A is negative, or if A is less than 0, it opens down. So I'm going to give you all of the keys on how to find this. This is going to be a super important thing for you to have to be able to refer back to later, because it's going to give you all your notes on how you can answer all of these things. My A is a positive 1, so my graph's going to open up. Then I need to find my axis of symmetry, that vertical line that goes up and down. So my axis of symmetry is x equals, here's a formula for you, x equals negative b divided by 2a. So again, you need this written down somewhere that you can refer back to it, because we're going to use that equation. So for this example, x equals negative, b is negative 2, divided by 2 times a is 1. So negative 2 is 2, over 2 times 1 is 2, which is just equals 1. So my axis of symmetry is x equals 1. To find your vertex, so we're kind of cheating because this is what we're going to do on lesson 11, but I'm going to draw that. My vertex is always on my axis. If this axis cuts it down the middle and that vertex is on the middle, then my vertex has to be somewhere on this line. So my vertex is an ordered pair. Where's my hot pink? We use this for the x coordinate, 1, because my point has to be on that line, so it has to have the same x coordinate. And then we're going to plug x in to find y. Right, so we have our equation up here. Y equals x squared, but our x is 1. So 1 squared minus 2 times x, but x is 1, plus 3. So 1 squared is 1, minus 2 plus 3 is 2. So my vertex would be at 1, 2 right there. Okay. 2, 1. So here's my vertex. That's my starting point. And we said that the graph opens up. So I'm not going to draw a nice one. We're just doing a little sketch to help us answer some questions here. If my graph opens up, then my graph is going to have a minimum. It's going to have a lowest point because the arrows are going to point up. So this graph has a minimum because it starts at the vertex and then just keeps going up forever. And what's the lowest point on that graph? The lowest point on that graph is at positive 2. So it has a minimum at 2. How about the x-intercepts? So to find x-intercepts, again, put this somewhere on there because you're going to need to know it. To find the x-intercepts, you can either factor and solve, or you can use quadratic formulas. So this is why we spent all of that time solving quadratics, because we need to be able to solve. Those solving finds our x coordinates. However, look at this one that we're sketching. Here's my vertex, and it goes up forever. It's never going to come down this way. So it's never going to cross the x-axis. This has no x-intercepts. So if you kind of figure out which way it opens and where the vertex is first, you'll know if you need to try to solve for x-intercepts. This one we don't need to. The domain for every parabola is negative infinity to infinity. As long as we're not talking about real world problems like the basketball wouldn't keep going forever. But as long as we're just talking about equations and graphs, it's infinity. And then the range. Okay, so smallest number first. What's the smallest on our y, up and down? What's the smallest number or the lowest it goes? The lowest my graph goes is right here at 2. What's the largest y? How big does it get? How tall or high does it get? It has these arrows, so it keeps going on forever. So the highest it reaches is forever, which is infinity. Okay, for our last one, I changed the equation, so we need to change it for multiple reasons. Okay, so my A is -4, B is -8, and C is 5. So my graph, this graph, since A is negative, my graph is going to open downward. So this graph opens down because A is negative. Okay. My axis of symmetry, remember you need the formula, x equals -b divided by 2 times A. So for this equation, negative, b is -8, divided by 2 times A, which is -4. -8 makes +8. 2 times -4 equals -8. So that is -1. And remember, your axis of symmetry is a line. So if you just put -1 right here, you won't get it right. It has to be an equation of a line, x equals -1. My vertex is an ordered pair. So that axis of symmetry, that number that you got, is the y coordinate. And then to find the x coordinate, anytime you find a y, if you have an x and you want to find a y, you plug it in. So to find the y coordinate, we plug x into the equation. So I get y equals -4 times -1 squared minus 8 times -1 plus 5. So y equals -1 squared is +1 times -4 is -4. -8 times -1 is +8 plus 5. So we get y equals, that makes 4 plus 5 is 9. That's the y coordinate of the vertex right here. So just like we did last time, I'm going to make a little bit of a sketch to help us. We know it's going to open down, and we know the vertex or the starting point is at -1, 9. Okay, so -1, 9 is right there. And because it opens down, my graph's going to go down like this. That means that this time it's going to hit the x-axis in 2 places. So I'm going to have to find 2 x coordinates, right? When I get down to the x-intercepts. This graph, I'm going to sketch it for now, but I'm going to erase it because it won't be accurate. So when I get there, I'll erase it. But this graph has a highest point, so it has a maximum. And what is that highest point? That highest point is up here at 9 because we started at -1, 9. So the highest point is at 9. It has 2 x-intercepts, 1, 2, that I could see, but we have to actually solve for them. To solve for them, you can either use quadratic formula or factor. So you look at this equation and you decide which you like better. Do you like quadratic formula better, or do you like factoring better? I'm going to have to go down below the line. I am going to use quadratic formula because the first term is a negative and I don't want to do that. So x equals -b, b is -8, plus or minus the square root of b, which is -8 squared, minus 4 times a is -4 times c is 5. All over 2 times a. So that makes that +8 plus or minus the square root. -8 squared is 64. This is going to end up being positive because I'm multiplying a negative and a negative. 5 times 4 is 20, times 4 is 80. All divided by 2 times negative 4 is negative 8. So 64 plus 80 is 144. Square root of 144 is 12. So we're going to get our two answers now. X equals 8 plus 12 over negative 8. And then you have to do the minus. 8 minus 12 over negative 8. 8 plus 12 is 20 over negative 8. And 8 minus 12 is negative 4 over negative 8. So we should reduce them. This reduces to 5 over 2. And this reduces to negative 1/2. So the two, we got nasty, end up with fractions. They could be worse. They could be irrational and horrible decimals. But negative 5/2 and negative 1/2 are my two x-intercepts. So negative 5/2, 0, and negative, oh, I forgot the y-intercept, negative 1/2, 0. I forgot to show you on the last one how to find the y-intercept. Let's add that down here. The y-intercept. The y-intercept, I can't talk on right. The y-intercept is just your c. So whatever c is, that's where it crosses. So you can tell my graph is not accurate. I had just put it down there to kind of help us a little bit. But my y-intercept is my c, so it crossed the y-axis at 5. 1, 2, 3, 4, 5. As an ordered pair, that's 0, 5. The domain is negative infinity to positive infinity for every parabola. And the range, what's the lowest this graph goes? Remember the first number is the lowest? The lowest it goes on forever. So that's infinity. And because it's down here in the negatives, that's negative infinity. What's the highest this graph goes? The highest it goes is up here at the maximum, and that it was at 9.